966 covers writing and converting between equations. Couple new equations that we'll introduce here in 966, one being point-slope form, second being standard form. And we all know slope-intercept is y equals mx plus b. Two new forms. Standard form is a linear equation of the form of ax plus by equals c. Big thing, a, b, and c have to be integers with the greatest common factor of 1. Point-slope form. The linear equation for point-slope form, here it is, y equals minus y1 equals m parentheses x minus x1. x1, y1, they're just a point or a coordinate, and m is your slope. Next portion, I want you to go ahead and write these equations down quickly, and we're going to make a comment about each equation here. So remember, slope-intercept form, y has to be by itself. Y is alone. Standard form, ax plus by equals c. One thing to note here, look at y is not by itself here. So when y is not by itself, it is not in slope-intercept form. This is called standard form, ax plus by equals c. Comment about this one? A, b, and c are all integers. You don't have any fractions, you don't have any decimals. They are integers, positive, negative, whole numbers. And last, our equation there for point-slope form, the two comments that you want to make about this are that your x1, y1 represents a point, and m represents slope in this equation. Hence the name point slope. Given a point, given a slope, point slope form. Example 1, we're going to start off with some point slope form. You are going to write the equation in point slope form. And then of the line given a point and given a slope, and then we're going to graph it. First thing, go ahead and write out the point slope equation. So there's our point slope equation. I also gave some headers to our ordered pair. -3 and 3. Well, that's an x1 and a y1 value. Now we're going to go ahead and substitute in accordingly with our slope and our point. So we have y minus in for y1 is going to be 3 equals our slope is -2. X minus and in for x1 we get -3. So there's -3 there. Next I'm going to go ahead and just write it without any parentheses here and get rid of that. We have x, look here, we have minus minus would give us a +3. So this would be our answer in point slope form. Now we're going to go ahead and graph. In order to graph point slope form, graph your point first, -3, 3. So from my origin, over 3, up 3, there's my plot. Second, use your slope to plot. So your slope is -2. To get a rise and run, make it a fraction. -2 over 1. There's your rise, and here's your run. So I'm going to go up 2. When I move up 2, remember this is going to be a negative slope, so I need to move to the left 1. There's my plot. Here's my two plots. Draw using a straight edge going through both plots. And there's the graph of that linear equation in point slope form. Example 2, same scenario. Try to use the same problem solve technique that we use in 1. So we need to go ahead and put it in point slope form. Write out the point slope form equation first. Secondly, put the headers above my point. So x1, y1. Here's my slope. Plug things in accordingly. So y minus in for y1 is 1 equals in for my slope here is 1/5. In x minus x1, x1 is going to be 5. I'm going to rewrite it without my parentheses here. So I have x minus 5. And here it is, that equation in point slope form given the point and the slope. Secondly, I need to go ahead and graph this. So I'm going to go over 5 up 1. Put my plot there first. My slope is 1/5, so I'll use my slope. Remember, the slope is positive, so I can't use the approach going up 1 for rise because I'd have to move to the right 5, and my graph isn't big enough. So I'm going to go down 1 over 5 to the left, get my point Now I have my 2 points, and that line is still increasing, so use this straight edge to go through those 2 points. And there it is, graphed, given a point and slope, point-slope form. Example 3, same scenario, write it in point-slope form. As you noticed here in this example, you're actually given 2 points, and there is no slope. So you have to actually find your slope first. Well, we can find slope with 2 points by the slope formula. So I'll have to find my slope first. Put those headers above there. Remember your slope formula, y2 minus y1 over x2 minus x1. So draw that template in. Substitute your values in to find your slope. Following your substitution, do your computation. We get -6 over minus here is going to be a plus 8. So we find out my slope when reduced is -3/4. Here's my slope. Here's that x1, y1 value. So I can put it in point slope form. First off, write that point slope equation. There's our point slope equation. Now substitute in your m value and your x1, y1 value as you did prior in the previous 2 examples. Everything there in red is substituted in. I'm just going to go ahead and rewrite this without my parentheses here. So we have minus as a plus, and there it is in point slope form. Example 4 says write each equation in standard form. If you look at the equation, they give it to us in point slope form. Standard form, ax plus by equals c. Remember, a, b, and c are all integers. So what we'll need to do first here is I'm going to go ahead and drop y plus 4 down equals. Next, I need to get rid of these parentheses by distributing. So 2 times x is 2x. 2 times 2 is a positive 4. Now remember, on one side we need to get the x's and y's. I have the y right now on the left side and the x right now on the right side. So I'm going to bring that over to the left side. So I'm going to subtract by 2x to both sides. When I do that, I get -2x. I would drop down my y value. I would drop down my 4 value. Equal sign lines up. The 2x's cancel out. I drop down 4. Still not in that order, because I still have over here a positive 4. Notice there is no constants on that side, so I need to get rid of it by subtracting 4 to both sides. After I subtract 4 from both sides, I get -2x plus y equals 0. This is in standard form. The reason why it's in standard form, remember, a is an integer. A is -2. -2 is an integer. In front of y really has a 1. 1 is an integer. And last, 0 is an integer. So those are all integers, so it is in standard form. This would be complete. Step 5, or problem 5, is a little bit different. It says write each equation in standard form. Now I look at this problem and I already see a problem. I see that we have a fraction here. I want to get rid of this fraction because standard form is ax plus by equals c. So let's get rid of that fraction. In order to get rid of that fraction, you are going to multiply by the denominator to get rid of the fraction. So in this case, I would multiply both sides by 5, and it would look like this. This is what the multiplication would look like to both sides there in red. I just also made a note that I multiply by the denominator to get rid of that exponent, and if we look at our fraction, it is -2/5. That denominator is 5, so I multiplied both sides by 5. Here I multiplied by 5 on the right side. There's my equal sign, and I multiplied by 5 on the left side. Now look what happens on the left side. I have to multiply everything on the left side. So I have to multiply. When I multiplied, I grouped my y minus 3. So what happens here is I have to distribute here. And we have 5 times y is 5y. We have 5 times -3 is -15. equals, I have 5 times negative 2/5. Well, when you do that, you get negative 2, and then you still have in parentheses x minus 5. So really, essentially, you are multiplying 5 into everything because you're taking 5 times negative 2/5 to get 2, and then 2 is going to multiply into x minus 5. So I'll drop everything down again. 5y minus 15 equals negative 2 times x is negative 2x, and negative 2 times negative 5 is a positive 10. Okay, done all that work, still not finished. We need to get this in standard form. Remember, ax plus by equals c. Don't lose sight of that goal. So get our x's and y's on one side and the constant c, the terms without variables, on the other. So in this problem, I am going to add 2x, and I would add 2x to both sides. I now have 2x plus 5y minus 15 equals, and on the right side, the only thing I have left here is 10. Still not finished. Ax plus by. Well, here's my ax plus by right there. So I need to get rid of 15. In order to get rid of that negative 15, I would need to add 15 to both sides. Now, when I add 15 to both sides, this is what we wind up with. 2x would drop down, plus 5y would drop down. 15s would cancel out, equals negative, or then we have 10 plus 15 is 25. This is now in standard form. As you notice, 2 is an integer, 5 is an integer, and 25 is an integer. That is your a, b, and c terms. Last problem that we have, we're going to write this equation in slope-intercept form. Slope-intercept form, y equals mx plus b form. Right now, if we look at the problem, we are given point slope. So in order to put this in slope-intercept, I'm just going to go ahead and drop y minus 2 down, equals, do your distributive property. We get negative 2/3 x. Negative 2/3 times a positive 3. When we do our computation, we get a negative 2. So it's still not in slope-intercept form because y here is not by itself. So we need to get y alone. In order to get y alone, I am going to add 2, because I need to get rid of minus 2. And I need to do that to both sides. When I do it to both sides, I am going to write it below 2 because they are like terms. Notice, I wouldn't write it below this term because that is not like term because it has an x. So I wrote it below my like term so I can do that computation. So I have y, 2's cancel out, equals negative 2/3 x would drop down, and we have a negative 2 plus 2. That would give us nothing, so we don't need to put plus 0, minus 0, and this would be it in slope-intercept form, y equals negative 2/3 x. This will conclude 966, writing and converting equations between forms.